From shadows to symmetry, a journey through the geometry of motion and space. This sheet explores the core journey found within the derivation sheet, tracing how a simple geometric rule evolves into a powerful tool for understanding complex environments. By looking through the lens of both a state diagram, which shows the evolving focus of our understanding, and a sequence diagram, which shows the step-by-step interaction between theory and visualization, we can see a clear path from simple circles to wiggling, three-dimensional surfaces. Phase 1. The foundation of discovery. The journey begins in a state of foundational certainty. We start with a simple, flat circular loop and establish a fundamental rule. The total circulation, or movement around the edge of a path, is directly tied to the amount of space trapped inside it. In this initial stage, the sequence of learning moves from a theoretical idea to a practical simulation. Through an interactive simulation, we see that as we use more points to define our circle, the numerical results align perfectly with our theoretical expectations. Phase 2. The wiggling world of 3D geometry. The sheet then shifts to a more complex state, the three-dimensional saddle shape. Here, the path is no longer flat. It wiggles up and down. This is where the state diagram highlights a purposeful transition in our intuition. While the math seems like it should become much harder, we discover a beautiful simplification. The sequence of discovery shows that even though the loop is twisted, the final result depends only on the loop's shadow, the flat projection it casts on the ground. Because the saddle is perfectly symmetrical, the vertical wiggles cancel each other out, proving that the essence of the problem remains rooted in the flat area it occupies. Phase 3. Beyond geometry to changing fields. In the final stage of the journey, we move beyond just looking at the shape and start looking at the forces passing through it. We transition to a state where the field itself is not constant. It changes strength and direction depending on where you are. The sequence of events concludes with a sophisticated visualization that uses color mapping to show how these varying forces interact with a curving surface. This final step demonstrates that while the geometry provides the stage, the local interactions between the field and the surface's orientation are what ultimately determine the final outcome. This progression, from flat circles to twisted shadows and finally to colorful maps of changing forces, shows that even the most complex mathematical relationships can be understood through symmetry and the power of perspective.